And so here's the difference array, one of the technique in data structure and algorithm, and it enable you to operate like do some certain operations in shorter time. So let's say if you have an array of size n, like this, the size. Oh, let me just go closer. The size of like n, and let's say you add or subtract some numbers from index I to index IL, or index beginning until the right or end. So it usually take, in worst case, it usually take, I mean, it takes big O of n, because you have to iterate from the beginning until the end, one by one, and the addition is just constant time. So the complexity is big O of n. But with this difference array, you can do the operation in big O of constant time, big O of 1. How you can do it is, um, let's say you have an array, original array like this here. This is a difference array, and you make the same, like an array of the same length first. For initialization, you copy the content at index 0 uh, from the original one to the difference array first. The rest is just follow this express this instruction. Uh, so for d at index I is calculated by this mathematical equation: array at index 1, index I minus array of index I minus 1. And this is the difference between these two elements, or adjacent elements. So let's say you get, let's say 2 and 3, and this index 1, index 2, and the same for difference array. And if you follow this equation, index at 1 is equal array of 1 minus array of 0, which is negative 3. Negative 3. So if you put the negative 3, and this represents the difference between like these two nodes, and do the same uh, to the rest of the elements in this difference array. So let's say it will be 1, because 3 minus 2 is 1, and do the same. Let's say it could be like this. What you can do is, these numbers representing the like difference between the number uh, before, like before the array, original array. So let's say if you want to add 1, or increment 1, or like to like all the elements from index, let's say if you wanna index 5 until index, let's say 7. So if you do this incrementation to the original array, it takes, you gotta visit this index 5 first, then 6 next, 7, and increment one by one. But with this difference operation, let's say I just added index 17. So if you do this, you're gonna visit all certain elements one by one, and that's quite inefficient, and it will take big O of n for this simple like addition like operation. But with the difference array, like let's say uh, so this, let's say this is the original array and of size n, and of course you need to make the difference array of size n as well. Difference array, whatever. Then of course you have these elements from index 0 until index n minus 1. But so let's say you wanna put like let's say here's the index 5, and here is the index 17. So of course you have it here as well. Um, the content in this area is very incremented by 1, and the like as I said, what this like numbers in this array, difference array, represent is the difference between no element and the element like before this index. So let's say if you focus on difference array at index 6, let's say so this is the index 6. You remember the equation here. So how you gonna calculate it is g of 6 is array of uh, 6 minus array of 5. But but the original array at like index 5 and 6 is both like incremented, so the difference between here and here, here and here is the same as the original array, same as the difference array, like that's saved here already. So you don't really have to update the number like between like let's say I'm going to just represent this target index as n instead of 6 or specific number. What you're gonna do is like the range, uh, my bad. So like difference array element of index um, n plus 1 until I put this so for target uh, I I'll name target as the index of the ending index. So so oh my gosh, my bad. So let me just clean it up and do that. And so I name this 6 as start, and I named end as 17. And so if you increment or subtract some specific number from like within this range, uh, like the different like corresponding like elements in difference array, it remains the same actually, because the difference between the array and the next array is doesn't change. So what you can say is difference array from start plus 1 until end remains the same. So what you need to update in difference array is only like for five, the difference between index, uh no, only this area has changed, and also array of 17 and 18, only this, like the difference between these has changed by the operation. So only uh, difference of index 6, because this equation to calculate this, and also difference of 18 has changed. So what you gotta do is just update these, um, just only what you gonna do is just update these two elements in the difference array, and let's say uh, hold on. So let's say then whenever you read this array, difference array, starting from uh, the like initial value, you can calculate any number at any index, uh, and you can recover the state after the operation like of this original array. So, and within like a constant time, and that's the advantages of this technique. And I'm going to look at the lead code program. Let me um, hold on. Array of zeros. Where's yesterday's uh, submissions? Yeah, in this lead code program, you look at here, so you get this original. Is it recorded? Yeah. So you get the original array nams, and the query kind of like operations, instructions. What I have done in my solution is just brute force solution, and yeah, so if you I just assume you already read the question. So what I have done is I decrement every single element within the range. Um, I I like I compared with zero, like compare with zero one by one, and whenever like if ever like above zero appears, then that means like this element couldn't be couldn't be like set to zero, uh, and if everything is below zero, then it returns true. That's my solution, and it actually works. If you, as a solution, it's correct, but not for lead code solution. So if you look at my like here, I tweeted and I solved like this way. Yeah, the same, and I actually got TLE. If you take a look at here, you can see almost all test cases are passed, but only three like caused TLE, because if you look at the constraint of the program here, you can see the length of the original array can be up to 10 to the power of 5, and the query could be up to like 10 to the power of 5. And if you do that in brute force way, then this like complexity of this solution could be big O of like n times m, which is 10 to the power of 10. And like I've heard that if your solution's complexity is above 10 to the power of 9, lead code throws like TLE, so it won't accept your solution. So that's why, yeah, my solution wasn't accepted. But instead, with like difference array, you can only solve uh, this question like with big O of uh, n, big O of n plus m, I guess, because it needs a big O of n to store define difference array like this, and it's gonna take m, or the number of queries, to calculate stuff like this. Query size, what is this? Yeah, this is operation, so q times, so, and each is constant time. So yeah, so within that, the complexity of these solutions gets down to like 10 to the power of 5, not 10 to the power of 10. So which can be accepted by LeetCode. So this is my finding for this today's LeetCode. Yeah, thank you.